both of these ways are writing it with components. These are both writing it with components. Okay, you could also write it by giving a magnitude and direction. So if you're in 2 dimensions, then you're typically the direction will be the angle with the positive x-axis. And then depending on the situation or the setting that you're in, if you're doing some kind of application, then also it can give you the angle, can give you the direction. Okay, so 2 ways to express it. This is one way, but the components, there's 2 ways to express with components, and then the magnitude and direction. So you'd say it's, now the magnitude from the component form, if you have the component form here, then the magnitude would be given by this formula here, which is the absolute value, okay, of a term. Okay. There's also other operations that you can do on vectors. There's vector addition and scalar multiplication. Those are going to work out best if you're in the component form. Okay, so adding 2 vectors together is just kind of what it seems like it should be. You just add the corresponding components. And then scalar multiplication is where you take like some number, let's say 2, and you multiply it by a vector like that. You just distribute it into all the parts. Okay, so that's an example of scalar multiplication. Okay, so let's take a look at exercise number 1. And number 1 kind of plays off this idea right here, that the vectors have to have both magnitude and direction. Okay, so who wants to read number 1? Does somebody want to read that?
I do.
Yes, okay, let's go ahead. So go ahead and start with A.
Copy the vectors in the figure and, oh, that's number 1, too, sorry. Are the following quantities vectors or scalars? Explain. The cost of a theater ticket. The cost of a theater ticket is a scalar because it only has magnitude.
Yeah, that's true. It's a scalar. So another thing is numbers are called scalars. So number 1 is scalar. Okay, so that's A. We'll go ahead and with part B.
The current in a river. The current in a river is a vector because it has both magnitude and direction.
Yes. And then the third one.
The initial flight path from Houston to Dallas. The initial flight path from Houston to Dallas is a vector because it has both magnitude and direction.
Yeah, that's true.
D, the population of the world. The population of the world is a scalar because it only has magnitude.
Yeah. So I'm just writing these down here just in case. Okay, so it's scalar because it only has magnitude. Okay, let's see if we get this right. Okay, good. We got all those right. Okay, number 2. Number 2 is they give us some vectors. I guess this is another way of expressing vectors. So here we have U is this right here. U goes like that. And then V, they have that pointing out this way, something like that. And then W is this thing right here that's going like that, or maybe more steep. So there's W right there. Looks like W is a little bit, I made W is a little bit too long. Okay, there we go. Okay, so we're supposed to find U plus V. So the idea here is that you're going to take this U and then, so basically one way to do it is you can start right here and do U and then tack the V right on the end of it like that. So this is like what V would look like, and here's what U would look like. And then the resulting would be this vector here. So yes, that would be u plus v. So let's see, which one of those is that? That's upper right. Yeah, so that's upper right. Okay, and then, okay, let's see. So u plus w, what's that one going to look like? I think there's a whole bunch of these.
Bottom left.
It goes
Bottom
right,
left.
it goes down.
Yes, that's going to be, wait. u plus v, wait, u plus w. Okay, so this one and this one. So that's actually going to go, it's going to come, so u is, yeah, so that's bottom right, right? Because u is going to be coming out like that, and then you tack w on the end of it, like that, and so the result's going to be over here like that, and that, so that's going to be the bottom right, right? Is that what you said? Okay, then v plus w. So v is going to be like right like this, and then, dang, I kind of got that off, and then w is going to come down right there. So the result is going to be something like that, which looks like bottom left. Okay, and then u minus v. So here's u. Now we're going to subtract v. So instead of going this way, when you subtract, instead of going like that, you go the opposite direction. So it's going to be like that. That would be negative v. And then, so the result's going to be like that. Which looks like top left. And then, dang, the next one is really tricky. So it's u plus, so v plus u plus w. So here's, you can do it in any order. So let's just start with u first, okay? Let's just start with u first. Although maybe I should just start with v first. Okay, so let's start with v first. Okay, so v goes up like that, right? And then u, plus you're adding u, so you're gonna come across like that. And then you're adding a w to it, so you're gonna go like that. And the result would be something like that. Looks like upper right to me, unless I got these off. Unless I messed up on these. Yeah. And then F is like the really hard one. So U starts with a U. Okay, good. I'm glad it starts with a U. So there's U. And then you subtract W. So W is like this. So you're going to go the other way. And then you subtract V. And so V is like this. So you go the other way. So you come down like that. And the result is going to be from here to there, which looks like upper left. Okay, let's see how many of those we got right. Oh, we got them all right. Okay. Let's move to the next problem, number 3. Okay, for number 3, what they're saying is that the vector A is the directed line segment. So A is the line segment from A to B. Okay, so when you do that one, what you want to do is you want to take the B components and subtract the A components from it. Okay, so you want to take the B component, the B point, and subtract the A from it. Okay. So for this first place, you're going to have 4 minus 0, because that's a 4 there and in the X spot and a 0 in the Y in the X spot. And then it's 2 minus 2. And then it's negative 4 minus 1. So that's going to be 4, 0, negative 5. Okay, and so that's, dang, I'm not sure how we're supposed to put that in there. Do you guys know how to put it into, Webassign? Put the answer in?
You just use parentheses.
Yes, just use the vector or the parentheses.
Yeah, so if you select the vectors, parentheses works too?
Yeah, parentheses work.
Okay, so what I did is
Works
over
as well.
on the calc pad, there's this vectors thing. If you click on that, then there's a thing where you can put the vector brackets. It allows you to put vector brackets. Okay, now we're supposed to graph this. Okay, so from last time, what we talked about was the Z axis is right there, and the Y axis is coming out this way, and then the X is coming straight out at us. So you want to go 4 on the X axis, and then 0 on the Y, and then negative 5 on the Z. That's going to be kind of hard. So let's say negative 5 is down here. So from the beginning point, dang. So we'll come down negative 5 from there. So from the beginning point, it's going to look something like this. But or if you take it, or it's also you're going to go from that point to that point. So it looks like the bottom right is the answer. Yeah. Okay, and then they also have the points right here. So they've labeled these 2 points right here and have it going from there to there. Okay, so for number 4, what we're supposed to do is find the sum of these 2 vectors, and that's not too bad. Just have to add the components. So that's going to be 2, 7, 1.
Wait, Brother Hirsch, so what was the answer for number A? Which one was it?
For A, what, 3A?
Yeah. Oh, or whatever, the picture one.
Oh, it's the bottom right.
Yeah, it's just the bottom right.
Oh, okay.
The bottom right one is the one that looks most closely like that one. Okay, and this one is just going to be that. Is it going to be the first answer? And then again, if you click the vectors, and then you can pull the brackets up that way. Okay, and then illustrate geometrically. Oh dear. Okay, so illustrating geometrically, that's a little bit more difficult. Okay, so you have the z-axis there, the y-axis over here, and the x-axis coming out that way. Okay, so we have this vector here, 2, 0, 2 in this direction, 0 in this direction, and 1 going up. So it's going to be, so that's going to be our A right there. Goes from the origin up to here. That's our vector A. And then our vector B is 0, 7, 0. So that from here, from this point, it's going to come out this way by 7. Okay, just it should be parallel to the y-axis, this vector B. And so the result is going to be from here to here. That would be A plus B. Okay, so let's see which one looks like it. It looks like the bottom left. Yeah, I think so. Yeah, so the bottom left is the one that looks most like this. Okay. Great, let's move along to number 5. Okay, so here they just have us doing a bunch of operations on these 2 vectors. So first of all, A plus B, just adding them together. And I suppose that we can flip it to the other format. So adding them together, you're adding the i's together, that's going to be 13. The j's is -4, and the k's is -6. So I believe you can just put it in as the vector in the vector form. So 13, -4, -6. Okay, and then part B introduces something called scalar multiplication, or kind of has you go over that. So 9a would be just multiply every one of these components by 9. So that's, let's see, 9 times 8 is 72. And then 9 times -4 is -36. And then 9 times 3 is 27. And then multiply 3 by everyone in the B component. So that's going to be 15, 0, because there's no J, so there's no Y component. And then 3 times -9, that's -27. And then just add those together, and, well, that's big. So that's going to be 87, -36, and 0. Okay, let's try that. Okay, and let's see, part C, does anybody remember what this is called when you have the absolute value signs around it in vectors? You guys don't remember? We said the word probably at least 10 times.
It makes it all positive?
Taylor said it, what's that?
Does it like change the direction just for the J value?
This right here?
Yeah. Oh, never mind. I don't know.
It's a word that starts with an M. And then an A. Taylor said it several times.
Is it magnitude?
Magnitude.
Yeah, it's magnitude. Okay, it's magnitude. Okay. So the absolute value of a vector is the magnitude. It's actually going to be a scalar. It's going to be a number. Okay, and so the formula was the square root of the sums of the squares of the components, right? So this is, so you take the 8, 4, and 3 and square those. Or rather -4, but if you're lazy, just put a 4 there. Like that. So 64 plus 16 plus 9. What does that add up to? 64 and 16 is 80, so that's 89. Okay, so that's just going to be a square root of 89. And this one's kind of interesting. You're going to take the difference of the two vectors. So a minus b, so this minus that one. So 8 minus 5 is 3. And then negative 4 minus 0 is negative 4. And then 3 plus 9 is 12. Okay, so you take the, you do this minus first, and then you calculate the magnitude. Nine and 16 and 144. Okay, so that's 144 and 9 and 16 is 160. It's the square root of 169. Hey, is that 13? The square root of 169 is 13. Yes,
I
it
think
is.
so.
Okay.
Yeah.
Okay, great. So let's go to number 6. Find a unit vector that has the same direction as this vector. Okay, so you remember that vectors have direction and magnitude. And if you multiply a vector by a scalar, it does not change the direction. So there's this principle right here. Multiplying by a scalar, so, oops. Does not change direction. Okay, so it's like if you're, let's say that you are pushing on a wall, okay, in a certain direction. And if you change how hard you push, but you're still pushing in the same direction, then you're not changing direction, right? But so changing how hard you push or pull on something, it doesn't necessarily change the direction, okay? So what you need to do here is if you have a vector, and to get the unit vector, if you divide by its magnitude, then you'll have magnitude 1. So like if the magnitude is 5 and you divide by 5, then the magnitude is going to be 1. Okay. So what we need to do is find the magnitude first, which is the square root of the sum of the squares of the components. So that's 64 and 1 and 16, which is the square root of 81. Whoa, that's 9. Okay, so if we just divide everything by 9, then that is going to have magnitude 1. Okay, so let's go ahead and input that. Okay, and then this unit vector right here, this is a unit vector in the same direction as that. If you were to multiply that by any number, then the magnitude would be that number. Okay, so for this next problem, what we're going to do is,
Hey, Brother Hurst,
yeah,
so for number 6, all you did was you found the magnitude by using the equation and then divided by the magnitude.
Yeah, divided by the
Every term-
magnitude.
every
Or,
term by magnitude.
yeah, or you could just say multiply it by 1 over the magnitude is another way of doing it. So I just took, so the magnitude is 9. I took each of the components and divide by 9.
Right, got it.
And then, okay, so this next one is you want, it's the same kind of concept except, so unit vector means that, so the unit means the length is 1, or the magnitude is 1. Okay, so here you want the length to be 2, which is double of 1, but whatever. Okay, so first of all, you find the magnitude. So that's 36 plus 9 plus 4, which is, well, these are working out to be nice numbers. So the magnitude is 7. So the unit vector would be this one, 6 over 7, 3 over 7, and negative 2 over 7, right? But if you want it to be 2, then you multiply this by 2. Okay, so it's going to be 12 over 7, 6 over 7, and negative 4 over 7. Okay, and that should be the answer right there. Okay, let's see if Webassign agrees. Okay, yes, okay, good. Okay, let's go to number 8. Okay, so the question here is, what is the angle between this vector and the positive x-axis? Okay, so this is just the 2 dimensions. So we can actually draw this. So this is 1 in the x direction. Okay, so this is kind of like looking at the point 1 square root of 6, right? So if you come 1 this way, and you come up square root to square root of 6 there, you get that, right? So that's the vector, and so the angle with the positive x-axis, the angle with the positive x-axis, that's going to be this right here. Okay, and so what this is sort of getting at is the other way that you can express vectors, and that is direction and magnitude, okay, rather than the component form. And so finding the angle that it makes with the positive x-axis, that would be direction. And then this, the length of this hypotenuse here, the length of the vector would be the magnitude, as we already know. Okay. So anyways, we want to know what that angle is. We know that this side is the square root of 6, and this side is 1. So what's the angle going to be?
Wouldn't this be root 6?
What's that?
Couldn't you do the inverse tangent of root 6 over 1?
Yeah, there's the inverse tangent of the square root of 6 over 1. Okay, because this angle, the tangent is square root of 6 over 1. So the angle is going to be the inverse tangent of that. Okay, oh dear.
68 degrees. Yes, 68 degrees.
Dang, Taylor, you're breaking up.
68 degrees.
How many degrees did you get?
68.
68 degrees. Okay. we'll take it. Dang, I gotta grab my calculator. Oh, dang. It says it wants it in degrees. Okay, so 68 degrees, it accepts it. Oh, where'd I put my calculator? Oh, there it is. Okay, so that's 68 degrees, the answer to that one. Okay, number 9. The quarterback throws a football with an angle of elevation 35 degrees and speed 50 feet per second. Okay, so this right here is the other way of expressing it because they're giving you an angle and magnitude. So the speed is the magnitude and this is the direction. And we're supposed to find the horizontal and vertical components. So we're given, so basically here, we're given the direction and the magnitude, and we're supposed to find the components. So we're supposed to put it back into the component form. Okay, so we know that, let's pretend that's the ground. And let's pretend that the quarterback is just lying on the ground and throws the ball like that. At an angle of 35 degrees. And this is 50. Okay. So, if we have a triangle like that, what is this? What are each of these sides going to be? If the hypotenuse is 50, and it's a right triangle, and this is 35 degrees, then what's this side going to be?
Sine. So you do 50 sine 35.
Exactly. And this one's going to be the cosine, right? Okay, so put your calculator into degrees mode. That doesn't sound right, putting your calculator in degrees mode. It's just, this just seems wrong to me. But let's do it anyways. Okay, so 50 sine of 35. Okay, so that one, I get 28. Let's do it to 1 decimal place, so 28.7. And then this one, um, 40.95, so we're gonna say 41.0. Okay, let's see if those answers work. So horizontal would be 41, and vertical would be 28.7. Okay, great. So this one is, so once again, this is vertical, and that's horizontal. Okay, number 10, find the magnitude of the resultant force and angle it makes at the positive axis. Okay, number 10, there's like a little drawing there, so I need to make the drawing. Okay, so here's the drawing right there. You have two vectors. You have A right there, and then you have B going back that way. And B has a magnitude of 300 newtons, and A has a magnitude of 100 newtons. And this angle here is 60 degrees. Okay, so basically you're gonna take these two vectors and add them together. And unfortunately, these are expressed as direction and magnitude, right? They're both just expressed as direction and magnitude. And when they're expressed as direction and magnitude, it's hard to add them together. They don't add together very easily. In fact, the best thing to do is what? So they're in direction and magnitude form, they're not easy to add together. But in component form, yeah, in component form, they are easy. So you're going to break them up into component form and add them that way. Okay, so this B one is not too bad to break up.
Brother Hurst, couldn't you also use the law of the cosines as well?
Maybe.
Oh, okay.
Well, let me think. I don't see any good way to do that. Maybe. But the easiest thing is, I think the only path is to put it in a component form. This is not too bad. It's just negative 300 on the in the X direction, right? The B is. So that one wasn't too bad. Okay, so let's see, what's A going to be? So here we can complete the triangle. This is 100. And this is 60 degrees. So if that's 60, then this is like a 1. This is like if you have a 60-degree angle, then it's like a 1, 2, √3, right? Okay, so what is the X component going to be? It's going to be 100 times what?
1/2.
What'd you say? Did you say cosine?
Oh, sorry. I was just looking at the special triangle. So
Oh, yeah. So if this is 100 instead of 2, if that's 100, then that means this would be
50.
50, right? Okay, so the X component is going to be, or we multiply by the cosine. So it's actually here. It's the cosine of 60 degrees, which is 1/2, right? And then this is going to multiply by the sine of 60 degrees, which is √3/2. So A is 50, and then 50 √3. Okay, and so A plus B, now we can add them together. It says 50 and the minus 300 gives you negative 250. And then 0 plus 50 √3, you get 50 √3. Okay. Okay, so that's the resultant force. Resultant means the sum of those ones. And so we want the magnitude, but we want the magnitude and the angle. Okay. Okay, so what's the magnitude, first of all? So the magnitude is this right here.
Be the square root of both of them squared.
Oh, dang. Okay, so let's see, what is that? 250 squared? That's a big number. Whoa, that's 70,000. So the square root of 70,000. So I get approximately 264.6. Okay, so that would be the first answer, 264.6. And then the next one is we want the angle. We want the angle with the positive x-axis. Okay. And so here we're actually going negative 250 and 50 root 3. We'll say that's 50 root 3 right there. And so you're over here, right? So what we want is this angle here. So what we can get is this reference angle by using this negative 250, by using 250 and 50 root 3. So this reference angle, we'll call it phi. That's going to be what? What's the reference angle going to be? The inverse tangent of what?
50 root 3 over, I don't know what the other one is. Oh, is it 260?
Over 250.
No.
250.
250.
Okay, so let's see. I still have my calculator in degrees mode. So 50 times the square root of 3 divided by 250. Okay, so that reference angle is approximately 19.1 degrees. So that means that the red angle, which is the one we're after, it'd be 180 minus 19.1, or 160.9. Okay, so that's what I'm going to go with and see if that works. 160.9. Okay, great. Any questions on that? That took a while, didn't it? Okay, let's move on to the next exercise. It's the last one of the section, too. Okay, so here we have the magnitude of velocity is called speed. Suppose the wind is blowing from the direction N45W at a speed of 40 kilometers. So that means that the direction it blows is 45 degrees west of the northerly direction. So let's see if we can draw a picture of what's going on. So this right here is the wind blowing. So let's put north going up. It's blowing 45 degrees west of the north. So this is north. So and then west is over here, right? So west is there, and east is go to the right. Okay. So the wind is blowing this direction at a speed of, and this is 45 degrees right here. And that magnitude is 40 kilometers per hour. Okay, so the pilot steering the direction, steering the plane. Okay, so that's the wind, right? That's the wind. And then the pilot is steering the plane in north 60 degrees east. So that's going to be over in this direction. So that's 60 degrees. Except it's going to be a lot. Whoa, the airspeed is, wait a minute, the airspeed, what? 100 kilometers per hour. Wait a minute. What? That sounds kind of weird. Can you even fly a plane at that speed? A 100 kilometers per hour. Wait a minute. How many miles per hour is that? That's like,
It's like 60 something.
it's like 60 miles per hour, 60 something miles per hour.
Yeah, you're just coasting.
Wait a minute. Was they just coasting?
Yeah.
Wait a minute. This is weird. Okay, so this is weird. Okay, well, let's just roll with it. Okay. Okay. So we're supposed to find the true course and the ground speed. So the true course would be the direction that the plane is actually moving, and then the ground speed would actually be the speed relative to the ground that the plane's moving. Okay. So
On the question, it says still air, so anything with that less speed doesn't need air to.
wait, what happened? Okay. So basically, we just need to add these two together. But again, adding them together is no good because you can't add them together if they're in the magnitude slash direction form. So we're going to put them in the component form. Okay, so let's start with the plane. And we'll go for component form. Okay, so what are the components going to be? You guys remember?
You just break it up in X and Y's, right?
Yeah, so what's the X component going to be? This is 100, and this is 60 degrees. That means that this right here is 30 degrees, right?
It would be 100. Oh no, because that's the hypotenuse. So it'd be.
Oh wait, hold on a second. Something occurred to me that oh dang. Oh yeah, just keep going. So that's, let's do the relative to the positive x-axis or the east axis, and then we'll
Cosine of 30.
right cosine 30, and then the
It'd be
y
100
component would be
sine 30.
100 sine 30. Yeah. Okay, so we'll go with that. Okay, and then so that's going to be the plane, and I guess we can go ahead and calculate that. So 100 times cosine 30, and then 100 times sine 30. Okay, so I have approximately 86.603, and then I have 50. Okay, now let's go with the wind. And the wind is going to be 40.
Use radian or degree mode.
It's in degrees. Yeah, so keep it in degrees mode. Okay, so 40. The wind is going to be 40, and it's going to be cosine of. Now this angle here is this overall angle is 45 plus 180, or 225. So that's going to be cosine of 225. And then 40 sine of 225. Okay, so 40 cosine of 225 and 40 sine of 225. Wait a minute. No. This is wrong. Okay, this is wrong. This is not 180. This is 90. Oops. So it should be 135. Okay, so that means that this is 135. Okay, so 40 cosine of 135 and 40 sine of 135. Okay, so here I have negative 28.28 and 284, and then I have positive 28.284. Okay, so then I can add them together. So adding those two together, I get approximately 114.887, and adding this and this together gives me approximately 78.284. Okay, so that's the sum. Now, what do we need to do now? We need to put it into, we need to put it back into component form. I mean, this is a component form. This is the sum in component form, and we need to put it back into direction and magnitude. Okay, so first of all, this is the direction is the first one, and they want it in terms of how far east of north you are. So, so this vector here is right here is like that, and that's 114.887, and then this height is 78.284. So we want to know what this angle is right here, and that will be the answer that goes in the in Webassign. This angle right here. Okay, so let's see, what is that? This angle here would be the inverse tangent of this divided by that, right? Okay, so I'm going to go inverse tangent of 78.784 divided by 114.887, and I get approximately 34.44. Okay, but that's this angle here. Our theta, which is what we're after to, would be 90 minus that.
Yeah.
Or 55.56. 55 point, wait a minute, one decimal place, so 55.6. Okay, and then the ground speed would be the magnitude of this. Would be the sum of the squares, right? The square root of the sum of the squares. Oops. So the square root of
Hey, brothers.
what do you guys get? About 139.0. Oh no, this is a disaster. Because that's not right. Oh dear. Oh no. I got it
Hey,
wrong. This
brothers.
is bad. Yeah.
I think you mistaken the 78 where you have the 10 inverse at the bottom right. You put it at 78.784 instead of 78.284. Is that correct?
Oh, okay. Okay. I think that's not enough to overcome what else is wrong with this. Well, that puts us at 34.3, which
Yeah, not much of a difference.
which changes this to 55.7. But I don't think that's going to be right either, unfortunately.
It's still wrong.
Boo. Okay, let's see if I can figure this. If we can figure this out.
Are the angles mixed up, Brother Hurst, where it should be 60 on the inside? Or is that correct?
Hi, Taylor.
Hey, Penny.
You still have your long hair?
So I think the N, well, it says, the instruction says that N45, well, that's 45 degrees west of the northerly direction. That's the northerly direction, right?
Right.
So 45 west would be over here. And 60 east would be over here, which means that's 30. So we're going by 30.
Oh, okay, that makes sense.
Okay, so I don't know what's up with that. How about, anybody did any calculations differently?
No.
It looks like I copied everything down right. Okay, so there's a problem with this. Let me try to figure it out and then get back with you tomorrow about it. Okay. And that would be the end. That would have been the end of the homework. Okay, so we'll figure that out tomorrow. Let's go ahead and go to 12.3. We'll just introduce that topic there. And then we'll figure out what's wrong with that later. Okay. So 12.3 is the dot product. So the dot product is an operation between two vectors. So So it's between two vectors, and the result is a number or called a scalar. And this is what the dot product, this is the formula for the dot product right there. Okay, so in order to, and it's a little dot, you do it with a little dot. It looks like a times, but it's different from times. It's not multiplication. Because you can't really multiply two vectors together. They can't be multiplied together, but you can take the dot product. There's also something else called the cross product, which we'll talk about later. That's another operation between two vectors. That gives you, then that one gives you another vector. But this one gives you a number, a scalar, okay? And so you can't take the dot product of a vector and a scalar, and you can't take the dot product of two scalars either, unless you consider them as vectors. Okay, so anyways, let's look at exercise number 1. And it says, which of the following expressions is meaningful? So part A is this guy right here, is A dot B dot C. Okay, so the thing is, so just to start this off, this right here, A dot B is going to give you a scalar, right? And so you can't take the dot product of a scalar and a vector. So this is this has no meaning because it's the dot product of a scalar and a vector. Okay. So that's the answer for the first part. No meaning because it's the dot product. I think I mixed up the N and the G. So you're trying to take the dot product of a scalar and a vector. Okay, so what is B? Anybody want to take a shot at part B?
A, B, C has meaning because it is a scalar multiple of a vector.
Yes, that's true. So it has meaning because it's a scalar multiple of a vector. Okay, what about part C? Okay, so B was this. And C is this right here. Anybody want to take a crack at part C?
Well, ABC has meaning because it is a product of a something.
Yeah, that's going to be a scalar. This is also going to be a scalar.
So is it two scalar?
Yeah, two scalars.
Okay.
Yep. Okay, what about this one right here?
That's gonna be a meaning in two vectors.
Yeah, because that's going to be a vector and that's going to be a vector right here. When you add those together, that's going to be a vector. So that's meaning, and you get two vectors. And then this one right here, when you take the dot product there, that's going to be a scalar, and that's going to be a vector. So that's going to have no meaning.
No meaning.
It's the sum of a scalar and a vector. Okay, and then the last one, this part's going to be a scalar, and that's going to be a vector. So, and this is a dot product though, so that's no meaning. Because you're trying to take the dot product of a scalar and a vector. Okay, great. So that's the introduction there. And let's move on to more problems. Let's do this page and then. So A dot B. So again, you take the corresponding, it's going to be a number, you take the corresponding values and multiply them together and then add. Okay, so the 7 times the 3, that's this one right here. And then the -2 and the 8, that's these ones. And then you do the multiplication first, of course. That's 21 minus 16, so that's going to be 5. Okay, this one right here. So that's this times this. And then this negative P times Q. And then this 6P times negative Q. So that's 2 PQ minus PQ minus 6 PQ. And that adds up to negative 5 PQ. If that works. Okay, and then the third one, it's back in this form right here, but you just have to keep the I's and the J's and the K's. Just keep those in order. Okay, and then the J is only going to have 2, and then there's no J over there, so that's multiplied by 0. And then the last ones is that's -1 and 9. Okay, so that adds up to -9 plus 0 minus 9, so -18. Okay, so for the next problems, we introduce this formula right here. The angle between two vectors is related to the dot product. Okay, so the dot product of two vectors is equal to the product of the magnitudes times the cosine of the angle between them. So if we know, for example, that if we know the magnitudes, which are these two, and we know the angle between, then we know that the dot product is equal to the product of the magnitudes, which is 40 times 30 in this case, times the cosine of the angle between them, 3 pi over 4. And let's see here, 3 pi over 4 is this angle right here. And so the cosine of 3 pi over 4 would be, let's see, that would be -1 and +1 squared root 2. So the cosine of cosine of 3 pi over 4 would be -1 over root 2. So if you multiply those two together, that's going to be 1200 over root 2. That's interesting. Let's see if that works. Okay, I did. What this formula is mostly used for is for finding the angle between two vectors. So you have two vectors and you want to know what's the angle between them. So we use this formula right here. This one right here. Or, I guess I didn't need to write all that down. Or we, the angle is going to be the inverse cosine of those. In this case, it's A dot B over the magnitudes. Okay, so let's see here. Let's calculate the magnitude of A and the magnitude of B. The magnitude of A is the square root of 1 plus 16 plus 1, so that's the square root of 18. Magnitude of B is the square root of 0 plus 25 plus 25, so that's the square root of 50. So that goes in the denominator, so 18 and 50. And then A dot B, the dot product of A and B, that's going to be 1. So no, it's going to be 0. So 1 times 0 plus negative 4 times 5 plus 1 times negative 5. That's negative 20 minus 5, that's negative 25 up in the numerator. And in the denominator, we have the square root of that's just a 30 in the denominator, isn't it? Because this is 900, and the square root of 900 is 30. So the inverse cosine of negative 5 over 6. But the, wait a minute. Yeah, inverse cosine of negative 5 over 6. Okay, so that's going to be the exact form. So this is exact, and then approximate. We just use the calculator to get the approximate form. So just plug that into the calculator. Let's see, inverse cosine of negative 5 over 6. I get 146 point. I get approximately 146.